Elementary Algebra, Final Assessment 3, Review. Questions 10 through 13. Outcome 3, Notation. Subtract and write the resulting polynomial in descending order of degree. In question number 10, we're given one polynomial subtracted from another. Let's go through first and just identify the degrees on each individual term within the two polynomials. If we look at the first term, 3x to the third power, that third power is telling us the degree. The degree on this one is 3. The degree on our second one is 5. The degree on our third one is 0. And the degree on our last one is 4. If we look at our second polynomial, the degree on the first term is 0. The degree on the second term is 4. The degree on the third term is 5. And the degree on the fourth term is 3. We're going to set this up to subtract from the first polynomial the second polynomial. But as we rewrite the first polynomial, we're going to rewrite it in descending order. We're going to start with the term with the highest degree, which is 2x to the fifth power. So we've already used this one, so we'll cross it out. Then we're going to go to the next term with the next highest degree, which is plus 9x to the fourth degree. Moving on to the third term, we have our positive 3x to the third degree, and lastly, our 1 to the to the 0 degree, plus 1. Now, what we're going to do is rewrite the second term under the first term, matching up the degrees. We have a 2x to the fifth degree. We have another fifth degree here. We'll stack it underneath. We have the 7x to the fifth degree, followed by the 6x to the fourth degree. You notice that my degrees are matching up with one another. Next, I have my minus 7x to the third degree, and then my 0 degree, which is a minus 5. Now in this case, we had the same terms raised to the same degree in each of the individual polynomials. If we had had, for example, a degree of 2 in our first and a degree of 3 in our second, we would have left a space, a blank space in between, so that we would have had somewhere to stack that next number. All right, but going back to this problem, everything matched up. What we're going to do is subtract now. We have a 2x to the fifth degree minus a 7x to the fifth degree. 2 minus 7 leaves us with a negative 5. We keep the variables raised to their degree the same, unchanged, carrying them down. Now we have a 9 minus a 6, which gives us a positive 3, so plus 3, carrying down that x to the fourth degree. Then we have a 3 minus a negative 7. If we put this minus and the negative together, it makes a plus. So this is 3 plus 7 to create a positive 10x to the third degree. Lastly, we have 1 minus a negative 5. Again, a minus and a negative are going to make a positive. So we have a 1 plus a 1 plus a 5 to create a positive 6. Our next problem, we're just told to multiply, and we're given 3 individual terms to multiply together. With multiplication, remember, the commutative property says that I can multiply these in any order. So I can multiply the 2x to the 7th to the second polynomial or to the third polynomial. I can even take the second and the third and multiply them together first, and come back and deal with the 2x later. Well, let's go in the order that they're given. Let's start by multiplying this 2x to the 7th to the 1/4 x, y, z. We'll come back and deal with the last term after multiplying these first two. So this 2x over 7, I'm going to put this into a fraction form, or at least put the 2 into a fraction form by placing it over 1, and that's because I have a fraction in my second term as well, with a 1/4 x, y, z. I want to multiply these together, so 2 times 1 creates a 2. 1 times 4 is going to create a 4. Now I want to take care of my variables. I have a x to the 7th power times an x. When multiplying variables, you simply sum together their exponents. So this has an exponent of 7, and this has an exponent of 1, even though we don't see it. Each of these have an exponent of 1. So this becomes x to the 8th power y z. I'm not quite done here though. I want to go ahead and reduce this fraction since I can. I can actually divide a 2 into both the numerator and the denominator. This would reduce this fraction down to 1/2 x to the 8th power y z. So that's combining the first two terms. I haven't multiplied, however, the third term in. So I'm going to go ahead and pull that third term down so that I can multiply it in. So I have a -2/7 y to the second z to the second. Next, I'm going to scroll this page down so we have a little bit more room to work. Now I'm going to multiply this 1/2 to this -2/7. So 1 times 2 is going to create a 2. 2 times a 7 creates a 14. Now I had a negative in here, so I don't want to lose that. I'm going to bring it back in. Now I'm going to go ahead and combine my variables. So I have an x to the 8th power. I don't have 1 to combine here, so it just carries over as is. I have a y to the first power with a y to the second power. So that creates 1 plus 2 to create a 3. Then I have a z to the first power to a z to the second power. So 1 plus 2 to create 3 again, so z to the third power. Again, I'm not quite done because I want to go ahead and reduce this fraction. Again, I can divide a 2 in the numerator and the denominator. So I keep the negative sign. A 2 into 2 leaves me with a 1. A 2 divided into 14 gives me 7. Then just carry down the variables as is. And there's my final answer. Alright, next the instructions read simplify. So I'm going to go ahead and simplify this problem. What I look at when I'm looking at this problem is if I look at the second term, I see the second term is overall raised to the 5th degree, or to an exponent of 5. That means that to simplify, before I do anything with the first term, I need to go ahead and distribute this 5 in onto each of the terms individually. As it distributes in, what it does is it multiplies to the exponents that already exist. So this is actually 2 to the first degree times a 5, an m to the third degree times a 5, and an n to the fourth degree times a 5, distributing that 5 onto each of the exponents. So when I look at this, this ends up being 2 to the 5th degree, m to the 15th degree, and then n to the 20th degree. Again, before I continue and bring down this first term, I still want to continue with simplifying, so I want to take care of this 2 to the 5th degree. This is like saying 2 times 2 times 2 times 2 times 2 5 times. So 2 raised to the 5th degree is going to create 32. M to the 15th, n to the 20th. Now I'm going to go ahead and go back and carry down this previous term. 3m to the 4th n to the 8th. Now this is showing multiplying. So what I'm going to do next is go ahead and distribute each individual part through. So I'm going to distribute this constant to this constant. I'm going to go ahead and distribute this variable m to the 4th power to this m to the 5th power, and this n to the 8th power to this n to the 20th power. So 3 times 32 is going to get me a 96. When we're looking at multiplying exponents together, what we're going to do is when we're looking at multiplying variables together, we look at adding their exponents. So here I've got a 4 plus a 15 to get me a 19. I have an n to the 8th to an n to the 20th, so 8 plus 20 is going to give me n to the 28th. So my final answer comes out as 96 m to the 19th n to the 28th. Question number 13's instructions read, multiply. So this means I'm going to distribute this negative 7/8x to the 4th to each individual term inside the parentheses. So I'm going to start by distributing this negative 7 to this negative 5. A negative 7 times a negative 5 creates a positive 35. Then I'll take care of distributing the variables to one another. So an a times an a gives me a to the 2nd power. This is a to the 1st, a to the 1st, 1 plus 1 is 2. Now let's take care of the x. I have an x to the 4th and an x to the 7th, so I'll add 4 plus 7 to get an 11. Next, I'm going to go ahead and move on and distribute this negative 7ax to the 4th to the second term, 10x to the 4th. A negative 7 times a 10 makes a negative 70, so I'm going to write minus 70. Moving on, a, but I don't have an a here, so this is just going to stay as it is, just a single a. I'm going to copy it down. Then I have an x to the 4th degree with an x to the 4th degree, 4 plus 4, which equals 8, x to the 8th degree. Lastly, I'm going to come in and I'm going to distribute this negative 7a to the x to this negative 10. So a negative 7 times a negative 10 makes a positive 70. An a, over here I don't have an a to multiply it to, so I just carry the a down unchanged. The same with the x to the 4th power. There's no x over here to add it to, so x to the 4th power. This is going to be my final answer.